Let us now look at special relativity and in particular length contraction. So again, we have to discuss proper length and then length that is contracted. So the proper length is the length measured in an object's rest frame. So we measure a length with a meter stick in the lab. That is the proper length. But if we try to measure the length of a meter stick while the meter stick is moving, then we're not going to measure the proper length anymore. So here we have an example. We have again a spaceship. It's moving with velocity v between the Earth and Neptune. And the distance that is measured by observers on the Earth, so the distance from Earth to Neptune, is known to be the proper length, L0. Note that this L0 will be the longer of the two distances that are going to be measured between Earth and Neptune. Then L is a distance that an observer on the spaceship will measure from Earth to Neptune. And then when we think about the time that the observer on Earth thinks the trip should take, remember that that time is a dilated time, and the time that the observer on the spaceship measures is actually the proper time, because the ship starts on Earth, ends up on Neptune, and an observer in the spaceship's reference frame will measure that time to be the proper time. Since the Earth observer measured the dilated time and the proper length, then the relationship between dilated time and proper length is delta t is proper length divided by the speed of the spaceship. While from the spaceship observer's point of view, they measure the proper time, but the contracted length. So we have delta t naught is L divided by V. So how do we figure out what this length contraction will give us? Remember that delta t is delta t naught divided by square root 1 minus v squared over c squared. So dilated time is proper time divided by square root of 1 minus v squared over c squared. If we now replace a delta t and delta t naught with these values, then we end up with L naught divided by v is equal to L over v times 1 over square root 1 minus v squared over c squared. So let's multiply both sides by v, and when we rearrange this, we end up with L equals L naught square root 1 minus v squared over c squared. So remember that v is much less than c, so v over c is less than 1. We subtract it from 1. This quantity gives us something that's less than 1. Multiplied by the proper length, we end up with a shorter length here, so that is the contracted length. So here we have length contraction. L is L naught, the proper length, times square root of 1 minus v squared over c squared.